start this one. If you go to the previous slides, okay, or at the end of the lecture, you will see the problems which you can practice from both the editions of the book, okay, for that topic. Now we are moving on to the third topic, which is a continuation of the second one. And in this one, we will be discussing the data collection and analysis for spot speed data and travel time data. Okay, I told you that these two things are always discussed together. Okay, we are still trying to cover the outcome of the course, which is related to the skills of data collection and analysis. Okay, so when we say we are doing spot speed studies, okay, spot speed studies means it should be a spot, right? Spot means what? If I say there is a spot on the board, that means what? A point, okay? So by definition, spot speed is on a point, okay? But to measure the speed on a point, then I need some detector or device, right? I cannot manually measure the speed of a vehicle on a point, okay? If you have a device, you can directly measure the spot speed, no problem. But sometimes we have a restriction that the device is not available, okay? Then what do we do? We do distance upon time, right? We do distance upon time, okay? So for that, then you need distance. It will not be a point, okay? But they have given us some margin that if your distance is under this limit, you can still consider it spot speed. Okay? Clear? Okay. So spot speed should be over a point. But if you don't have the detector to measure over a point, you can do distance upon time. But the distance should be under this limit. Clear? Why do we do spot speed studies? To find out the choice of the speed for drivers. Spot speed studies are done to find out the choice of speed by the drivers. Okay, at what speed they would like to go in these road conditions. Obviously, drivers select speed on the basis of the road conditions, right? Okay, slippery, bad, good, whatever. Narrow road, maybe speed is less. Wide road, the speed is more, and so on. Okay, so the choice of the speed regarding based on road condition. This is the main aim. I want to know the choice of the speed for the drivers. I will do spot speed studies. But that also means the driver should have the choice, right? He should not be forced. He should not be forced. So I have to do it in free flow conditions. Okay, the traffic conditions should be such that he can choose the speed. Okay, if I already have a long queue in front of me, I don't have the choice, right? If I already have a long queue in front of me, I don't have a choice. I will follow them, right? Okay, so that's why we have to do it in free flow conditions. Okay, now free flow means what? Free flow means this. Okay, the volume should be under these limits. The volume should be under these limits to be called free flow. Okay, if it is more than them, more than 1000 is not free flow in any case. Okay, less than 500 is free flow in all cases. Clear? Okay. Okay, so 500 is for smaller roads. Like if you have 2-lane roads, then 500 is good enough for it. But if you have bigger highways, major highways, then you can even go up to 1000 as well, no problem. So you can call it free flow. Okay. So I want to know the choice of the driver. So I will do free flow. I will do spot speed studies. If I have the detector, I can do spot speed directly. If I don't have a detector, then I have to keep my distance under this range. Okay. Then to make it free flow, the traffic flow should also be less. Otherwise, the driver doesn't have the choice. So how much it should be less? We have the limits here. Clear? Okay. once you have the spot speed data, meaning the choice of the driver, where can we use it? Okay, the first use is setting up the speed limits. Something which I mentioned in the last chapter as well. The speed limits are not set randomly. They should be as per the expectation of the driver. Okay, and according to the road conditions. Okay, so the driver has a very wide road in front of him, straight road, and they have shoulders and medians and everything. And you are giving the speed limit 50 kilometers per hour. Okay, it's useless. Okay, nobody will follow it. Right? And the other way around is also true. You have 2-lane road, no shoulders, you have walls on the side, and you are asking the driver to go at 120 km per hour. Okay, in both these cases, the speed limit is useless. The driver cannot go up to that way. Okay, so a speed limit must be according to the expectation of the driver. The expectation of the driver is his choice. Clear? Okay. The second application of spot speed data is the design. When you are designing the road, the bridges, the road signs, they are as per the speed of the driver. Okay, you calculate side distances, right? Okay, side distance needs speed. Which is speed? Any speed. We'll do the spot speed studies. Clear? Okay, so spot speed studies are also used in the design of the road. Some examples are mentioned here. We are designing a curve, vertical curve, horizontal curve, side distance, and gradient, and so on and so forth. And then we have the design of the signals. Okay, so they are the design of the signal itself, the pole. Okay, how high it should be it be vertical or horizontal or what? Okay, this is also depending upon speed. And then we have the design of the signal timings. Signal timing is also on the basis of speed. Which is speed? Again, spot speed. Clear? Okay. And then we have the last one, which is for accident locations. Okay. Again, something which I mentioned. The speed and accidents are very closely related to each other. Okay. So, spot speed, we do the spot speed studies because they present the worst case. Choice of the driver will be high speed, right? Choice of the driver will be to go at high speed, and the accidents which happen at high speed are more severe. Okay, and there are more chances of accidents at high speed as well, right? So that's why for high accident locations we do the spot speed studies as well. Before we go into the calculations, we must understand few terms. Okay, some of them you already know. For example, average or mean, right? You know how to calculate average or mean. Now, which part of the data is average or mean? The upper, the lower, the middle, the what? What part of the data is considered mean? The middle, right? Okay, so this is around the middle of the data. Okay, average is around the middle of the data. And then we have a standard deviation. The mean is one value, right? Mean is one value. All values are equal to mean? No. Okay. So you can have a mean, and then there are different values which have some difference from the mean, right? So if you take the differences of all values and do the average of the differences, that is called standard deviation. Okay. So mean is in the middle, and standard deviation is the difference from the middle. The average difference from the middle. Clear? That's it. Clear? Sure. You found the slides. Okay, then we have the 85th percentile. Okay, now percentile means what? Anyone? What is a percentile? Very good answer.
Skim from the word percentage.
Percentile and average is there. Standard deviation. Standard deviation. Yeah. Traffic is standard.
Percentage for
Percentage?
percentage of specific data.
Yeah. Okay. Good. Good. So percentile is this percentage, a specific percentage of the data falls in that range. Okay, it's a range for a specific percentage of the data. So if I say my 85th percentile is 60, 85th percentile is 60. So 85% of the data is in the range of 60. Okay, 85% data is in the range of 60. Okay, clear? So why we are mentioning 85th percentile here? Because this is our design value. Our design is based on 85th percentile. Okay, so we base our design on the value which is a range of 85% of the data. Yeah? Okay. Then we have median. What is median? Median is median. Yeah. What is median?
Sum of number over number.
There is mean.
It is the middle value of
Middle value. Very good. Yes.
middle value.
Huh? You agree with that? Okay. So yes, it's a middle value. Now which percentile is it?
55.
58%.
Oh.
Okay. Then we have pace. Okay, pace is not a value, it's a range. Okay, and the difference of this range is 10 miles per hour. The difference of this range, the pace range, is 10 miles per hour. So if the start value is 10, the end value will be 20. Okay, if the start value is 25, the end value will be if the difference is 10, if the start value is 25, the end value should be, what is 25%? 35. Some people when they come from their house, they say, I will not say anything to you. No? You will say it now, right? Okay. So it's a range of 10. Okay, so whatever the last value is, the end value will be that plus 10. Okay, there. So I can have, so my data goes from, for example, 0 to 60. The first value is 0, the last value is 60. Okay. So I can have a range of 10 from 0 to 10, right? And I can have it from 1 to 11 as well. 2 to 12, right? All these are intervals of 10, right? So any one of them can be pace. Because of the interval, any one of them can be pace. Okay? But which one we will select as the pace? That one which has the highest percentage of drivers. Okay? So for example, we are doing it for the spot speed, right? Free flow conditions. Remember? Free flow conditions. Okay? So the percentage of drivers driving between 0 and 10 will be very low, right? Because there is almost no traffic. Okay? So very few drivers will be driving in the low range. If you go up, so if you go from 0 to 10, very few drivers. You go from 10 to 20, you will find some drivers, right? 20 to 30, more drivers, right? If you keep on going up and up and up, the percentage of drivers will keep on increasing, right? But then you will reach a limit after which it will start going down, right? Okay, because you cannot keep on going up. Huh? So maybe at 100 miles per hour, you will again find very few drivers. Okay, so there is a middle portion where the percentage goes very high. Before and after it is very low. Okay, so we are looking for that middle portion where the percentage of drivers is the highest. Clear? Any questions? Okay. Okay, we can collect speed data using handheld devices. I am talking about spot speed data, remember. So you can use some devices which are handheld, portable, or you can use some devices which are permanently installed on the road. Okay, a device which is permanently installed on the road is called as a loop detector, one of the devices which you can install on the road, for speed is called a loop detector. Okay, a loop detector looks like this. It's under the road, but you can see the marking on the pavement near the signals, especially at many signals, many big signals in Bahrain. You will see on top of the road a marking like this, like a rectangle. Okay, so most probably under it is a loop detector. Okay, and you can see why we call it a loop, because it has two ends. We are going in this direction. Oh, sorry, this direction. Okay, so you cross the first part and then you reach the second part. Between them I have some distance, right? So it will note down distance, time from here to here, and then it will do distance upon time for you. Okay, so this is a permanent device which you can use for, I'm saying permanent because it's installed under the road, right? You cannot just take it out after 2 hours. Okay, so this is one of them, and then we have the other handheld devices, detectors, radars, guns. Okay, these are different names for speed measuring devices. Sometimes we call them radar, sometimes we call them gun, sometimes whatever. Okay, but you can hold them in your hand and take the observations, or you can use it like surveying instruments. You have seen surveying instruments, right? Levels and certain lights and so on, right? So you put them on the stand, right? And then you align them, and then you take the observation, right? The same type of speed measuring devices are available. Put them on the stand, align them to the road, and when the car passes, you press the button, it will give you the observation. Clear? Okay. So there are different methods to calculate or to collect spot speed data. Once you have the speed data, we don't keep them as separate values. Okay. Now, by the way, for the next presentation of your term project, this is what we have to do. This is one part of it. Doing a spot speed studies. Okay, so you have to take care of all these things. There should be free flow. If you are doing it using a stopwatch, then the distance should be less than the range and everything. Okay. So once you have the speed values, we don't keep them as values. We put them into groups. Okay. So for example, my lowest value is 20 and my highest value is 80. Okay. Now this range will be divided into small groups. So for example, 20 to 25, then 25 to 30, then 30 to 35, and so on. Okay. You can decide the groups, no problem. Okay. So we divide them into groups. Okay. In each group, and we call them as speed groups. Okay. The groups which you made are called as speed groups. Okay. For each speed group, I will note down how many drivers were in that range. How many drivers were in that group. Okay. So for example, I have a group from 20 to 25. Any driver who was driving in this range will be counted of this group. Okay. And this count is called as frequencies. Okay. So we don't have values of speeds. We have speed groups, and for each group I have a frequency. Clear? I'll show you an example here. Okay, so you can see the speed group over here, and these two columns are showing the frequencies. This with lines, 10 lines, no? And this is the number of the lines. Okay, why do we have the 10 lines? Because of counting. And you will do the counting for the project as well. Okay, so we use lines because it's easier in the field. Keep on making lines instead of the numbers. Numbers have more chance of error. So do the lines. Okay, so each line is 1, and the diagonal line is 5. Okay, so and then you see the numbers on the side of the video. Clear? Okay. Okay, there are some recommendations for the speed groups. Okay, the speed group should not be more than 5 miles per hour. The size of the group should not be more than 5 miles per hour. Okay, and the recommended value is 2. The recommended value is 2. Okay, so more than 5 we should not make it. Okay, so we are starting from 30, then 30 to 36, not acceptable. Okay, it should be 35 or less. Okay, and 2 is considered as the optimum size, recommended size. So 30, like they are showing here, is the size of 2, right? The group has a size of 2. But this is not fixed. You can make it less than 2 or more than 2, no problem. All values are in miles per hour. So when they say 5 miles per hour. When they say 2 miles per hour. Okay, and these are empirical values, so we take them as it is. You cannot say if it is 2 miles per hour, you will take it 2 kilometers per hour. No. 2 miles per hour is 3 point something kilometers per hour. So you have to do the conversion. Clear? Okay. Yeah, and the group size, we have to keep in mind that when you are selecting the group size, so I told you, you have the option. You can do less than 2, more than 2, but not more than 5. Okay, so for example, if I take a group size of 1, it is correct, no problem. If I take group size of 3, it is correct, no problem. But then you have to look at the values. Okay, if you select a group size, in which all the values are done in 2 groups, that's not good. Got my point? You have selected a group size, for example 5. 5 is allowed, okay? But when you select the group size as 5, all values are finished in 2 groups. This is not good, okay? So select the group size so that you have values in many groups. Okay, we want to make a significant number of groups. Okay, so if you are selecting a size that all values will fit in 2 or 3 groups, it's not good. Okay, so I selected a size of 5 and all values are finished in 2 groups. It's not good. If I select a smaller size, maybe 3, then I will have more groups with values. Got it? Okay, so the other things you have to keep in mind. Now look at this table. This table shows some of the calculations, very basic calculations with the data. Okay, so the first 2 columns are the speed groups. Okay, the first 2 columns are the speed groups. We select them. I told you. 2 is recommended, 5 is maximum, and so on. Okay, so we select them. Okay, the third column is middle speed. Middle of what? The first 2 values. Okay, so you see the first column, the first row 30 and 32, right? Middle is what? 31. Okay, and who is selecting the first 2 columns? V. Together. So when we select the first 2 columns, we are also fixing the third column as well, right? Third column is the middle value. Okay, so when you select the first 2 values, the third value is also fixed. Clear? Okay. Now the fourth column is number of values in each group. How many drivers were in each group? Okay. And from where do I get these values? Yes. This is from the study of the road. Okay. So there is no calculation here. There is no fixing here. Okay. No selection here. Whatever values you observe, you just put them in here as it is. Okay? Clear? Okay? They could be any values. Okay? They could be 500 values in one group, 100 in the other group, whatever. Okay? So this is observed data. The fourth column is observed data. Okay? How many drivers in each group? And what did we call them? We have speed groups and we have what? Frequencies. Okay? So this N is the frequency. Okay. Then we have percentage. How do we calculate the percentage?
The part over the total.
Okay. So this is percentage of frequency. Take frequency from each row divided by the total. How much is the total?
100.
How much is the total?
368.
368. Okay. Total of the frequencies. Okay. Clear? Okay. Then cumulative percentage. We add the percentage frequencies. Okay. So the first one is 0 because this is the first one. Second one is first to the second. I'm talking about this column. Okay. first one is same, the second one is addition of these two, third one is addition of 3 and 4 and so on. Clear? Any questions? Okay. This column n into s. Where is n? Where is s? Which columns? N is number of vehicles, fourth column, right? And s is third column, middle speed. Okay. And this one again, instead of n into s, you do n into s square. Okay. So n is again fourth column, and s is the third column, square of the third column. Clear? Clear? Any questions?
Victor,
Yes.
when we have an even number for the speed, what's the middle will be? Like 4 miles per hour. What's the middle will be? Middle speed.
What do you mean?
We have 30 to
34. Middle will be 32.
Oh, okay.
Okay. Now, if you have a speed, if there's a driver who is driving exactly at 34, his exact speed is 34. Tell me, will he be in the second group or the third group? Second group. Because the third group is greater than 34. Okay, so I cannot put it here. So you have to keep in mind. Okay, the lower limit has a greater than sign. Okay, clear? Clear? Any problem till now? From this data, we will plot two curves. These two curves. Okay. So the first curve is between middle speed and percentage frequency. We call it the frequency distribution curve. The first curve is frequency distribution curve. Middle speed and the percentage frequency. Okay. Can you tell me the columns here? Which columns?
Third and fifth.
Third is the middle speed, so it will be on the x-axis. Okay. And which one? Yes? Fifth. It will be on the y-axis. Percentage frequency. Got it? Okay. Then the next one is called cumulative percentage frequency. Okay. That means the what? Maximum upper limit of the speed group is on the x-axis and cumulative percentage is on the y-axis. Okay. So which column on the x-axis? Second column. Okay. And the sixth column on the y-axis. Clear? Clear? Okay. Now you can see here that these figures, okay, they are closing at the axes, right? They start and end is at the axis. Okay, the x-axis, right? Okay. Now if they are closing at the x-axis, so the y value is how much? 0. Okay, the y value is 0. Okay. Y value is a frequency, right? Y value is what? Frequency. So that means what? I have a group at the start which has 0 value, right? And have a group at the end which has 0 value. Okay. Can I put these groups out of the data? I can. I don't have any data in these groups, right? Okay. I don't have any data in the first group and the last group. I can take these groups out. My data will be complete, right? Will I miss any values? No. These groups have 0 values, right? If I remove the first one, I will not miss any value, right? If I remove the last one, I will not miss any values. But without them, my curve will not be closed. It will not reach here, right? Without these groups, my curve will not reach the axis. So that's why I'm keeping it. Okay? That's why we are keeping the two groups. Okay? In some other calculation, we will kick them out. Okay? In other calculation, we will kick them out. But for the time being, for the curve, I am keeping them. Clear? Okay? Same thing here as well in this curve. It starts from the axis, right? Starts from the axis and ends where? Huh? It starts from the x-axis but ends where? What's the end value? Second curve. Yes. What is the end value of the second curve? What axis? Is this the axis?
Start with 0% and we end with
100%. Okay, 100%. Okay, you cannot have two axes. One is 0, one is 100.
Doctor, it's not closed, the two curves.
Yeah.
So when we don't have this data 0, we will add them.
What? You will add them. Yes. You will add them. Yes. Faisal Muhammad. You are Faisal Muhammad. And you are the other one.
Which one?
Your name?
Muhammad.
Muhammad, okay. Faisal Hussain. No, right? Muhammad Abdullah. Okay, what are we saying? Yeah, so we have to close the curve, that's why we have these groups, otherwise we can take them out. Okay, clear? Okay. Now if you, the second one is not a good example, but the first one, if you look at the first one, you see all the points are not on the curve, right? All points are not on the curve. Okay. So this curve is not drawn by joining all the points. We call it the best fit curve. Okay, so if you are using any software to draw these curves, there is an option to draw the best fit curve. You give the data to the software and ask it to draw the best fit curve. Okay, so it will draw the best fit curve, which means it will not join all the points. Okay, it will not join all the points. Okay, so why do I join all the points? Because of the shape of the curve. If you try to join all the points, you will see what will happen to the shape. It will be up and down, right? For example, if I go from here to here, it will go up and then down. Okay, same thing will happen somewhere here. I'm going up and then sideways and then up again. Okay, so it will destroy the shape. Okay, so best fit curve is used where I know that the curve should be in a specific shape. Okay, why we are ignoring the points? Because real world data has random errors. So it will never follow the exact shape. Okay, real world data does not follow the exact shape, never. Okay, whether you are doing experiments in the lab, whether you are collecting traffic data, weather data, whatever data you are collecting, it does not follow the exact shape. Okay, because it changes randomly. Okay, but should I, if you look at the curve, all points are almost on the curve, right? So because of 1 or 2 points, why should I destroy my curve? Okay, so we keep the shape, okay, and we stay close to the points. It's not exactly on the points, but it is close to the points. Clear? Okay. Okay. Once we have the data, we can calculate two types of statistics with the data. Okay, one is called the center tendency, the other one is called the dispersion. Okay, central means the values in the center. Okay, the values which are in the center. Okay, and dispersion means variation. Okay, how much is the variation in the data? So center tendency means where is the center of the data, and dispersion means how much is the variation, dispersion or variation in the data. Okay, clear? In Arabic they call it what? Variation. Ta'addud. It is not counting. Ta'addud is not counting.
Add counting.
Ours is counting. Okay.
Ta'addud is variation.
Variation. Huh? Is it correct? Okay. So, the first of the central tendency statistics is, we will only discuss central tendency today. The first of the central tendency statistics is mean. We said mean is in the center, right? Mean is somewhere near the center. Now, how do we calculate the mean? How do we calculate mean?
Sum
Over sum over number, right? Sum over number. Okay? This is how we calculate the mean. When we have values. This is how we calculate mean when we have values. Okay? But we did what with our data? Do we have the values? We don't have the values. We have what? We have speed groups and we have number of vehicles, right? Frequencies. Okay? So there is no values to add here. There are no values to add. Okay? So to use this, then we have to use this equation. This is the equation we use for frequency or group data. Okay? So we have to do summation n into s. Okay? Is it done? Where is summation n into s? Okay? This is n into s for each group and this is the summation. Okay? Now what is capital N here? Capital N is the total number of frequencies. Yeah, this one. Okay, clear? Huh? How much is this? Okay, so summation n to s upon total 48.2 miles per hour because the speed is miles. Clear? Okay, any questions? Okay. The other measures of central tendency will be calculated from these two graphs. That's why you plotted the graphs. Okay, other measures of central tendency will be taken from the graphs. Okay. The first one is a median. Okay, and we said median is a percentile. Which percentile? 50th percentile. Okay. Now keep one thing in mind. We will calculate or find out other percentiles as well. All percentiles are taken from this graph, cumulative frequency graph. All percentiles. Whether it's 50 or 85 or 15 or whatever. Okay. All percentiles are from the second graph, cumulative frequency graph. Okay. So on the y-axis I have cumulative percentage frequency, right? Which percentage I am looking for? Median has these which percentage? 50, right? So I'll go to 50, then go to the curve and find out the speed. Now remember, all these are speed values. Mean was the speed, right? 48.2 miles per hour, right? Median is a speed. Where is the speed? On the x-axis. Okay, so don't tell me my median was 50. Median has a percentile of 50. You still have to find out what is the speed at 50. Clear? Okay. So median, you go to cumulative frequency graph, 50, go to the curve, find out the speed. Simple? The second one is mode. What is mode? Most repeated number, right? Okay. Most repeated number will have the highest frequency, right? Most repeated number will have the highest frequency. Now from which graph I should pick this number? First or the second? Huh? First, why not the second one?
Because there is no number of frequency.
It is. It's cumulative. Okay. So if you use the second one, you will always have the last one, right? If you use the second one for the mode, the highest one is always the last one, right? We are adding, right? So highest one is always the last one. Okay. Mode comes from the first graph. Okay, just remember. Mode comes from the first graph. Okay. We are looking for what? Highest frequency, right? Highest frequency. Okay. So you see the point of the highest frequency, right? On the top. Then from that point, I go where? Y-axis or x-axis? X-axis. Because I am looking for speed. Okay. I go to the x-axis. Go down, you come to the x-axis, find out how much is the speed when the frequency is maximum. When the frequency is maximum. Is the speed maximum? I am looking for the speed when the frequency is maximum. Clear? Okay. You go to the highest point, drop down on the speed axis. Clear? Okay. The last thing is the pace. Okay. What was the interval of pace? 10. Okay. So what do we do? We take a scale. Okay, and we come to the graph. I want a scale which has a length of 10. I want a scale which has a length of 10 because my pace has a range of 10. Okay, any 10? Can I just take this as pace? 30 to 40?
Most
No.
repetition.
Most, which has the most repetition of drivers, right? Where is the most repetition of the driver? Near the peak, right? So what will I do? I'll shift my scale towards the peak. Okay. How much should I shift? So your scale has two edges, right? Two ends. Okay. One end should be on one side of the peak touching the curve. The other end should be on other side of the peak touching the curve. There you will stop. Okay. So pick a scale of 10 miles per hour. Then you shift it towards the peak. Keep on moving it. Okay. When you are near the peak, in a condition that one end is touching the graph, the other end is also touching the graph, and they are on both sides of the peak. There you stop. Okay. So this is the scale, and this is where they stop. You can see one side touching one side of the peak, the other side touching the other side of the peak. Okay. So this is my pace from here to here. Clear? Any questions? Okay.
It's wider, cannot be touched in 10
No, and then there's not a problem of the width, it's a problem of the height. Okay, so for example, my scale is, this is small, so I'm here, but it's not tall enough. So I'll increase the height. I'll go vertically up and see if it is touching the, I'll extend it. Okay, I'll extend it. But it has to be 10. You cannot make it wider. It has to be 10. You can make it taller. Clear? Okay. Any other question? Okay. Thank you.